Last session we have discussed the structure of the C program, right. In that structure we have discussed how we need to begin with the program. Always we need to begin with the program comment section. So, always if you have any documentation with respect to the program, you need to put it in the comment section, and then if you want to include any header files, you can include the header files in the header file section. That should be the beginning of the program. And then if you have any global variable declaration after the header file declaration, you can include those global variables, then we will write the main function. That is what we have discussed in the last session, the complete structure of the C program, and also we have seen the example of C program. So, today we will try to understand how to compile and then execute the programs, because already we have discussed why do we need compilation, because the program what we write, or here what we are using the C program, which we are using in the high level program language. Your machine can't understand those instructions. So, that has to be need to be translated into the machine level language. So, that is the reason we are going to use the compiler here to translate from high level language to the machine level language. So, now just to understand how we need to convert that into a machine level language, that is a compilation. Once the compilation is done, that means no errors with respect to the syntactically, we do not have any errors, then we go and execute those programs. So, now we will try to understand how step wise we will try to understand how to compile and execute the program. Here we use the translator as a compiler. Compiler is a software program that analyzes the instructions. So, basically whatever the instructions we have given to accomplish particular specific task. So, first your program, your compiler will try to analyze all those instructions which we have developed in C programming here with respect to, because we are talking about C program, yes, maybe any language, yes, same procedure only, but here the instructions which we have written in C program, it will try to analyze that and then it will translate it into a form. Which form? That should be suitable for the execution on a particular computer system, because at end of the day, or ultimately the computer has to understand all those instructions, what exactly you have written, what kind of instructions you have given to write or to perform something. So, basically to implement that, we are using the compiler here. So, the same procedure we will try to understand the stepwise. So, basically how the first step we need to begin, and then how many steps we need to continue till to reach the execution or till we get the output. What is the first step here? Always we need to the first we need to be compiled. The program that is to be compiled is first we need to open a notepad or some of the editor. In that editor we will write or we will type all the instructions to perform a specific task. Maybe you take up some example, addition of two numbers, that is a task. To add or addition of these two numbers, we need to write some instructions. So, those instructions first we will write or we will type in one particular file on the system. So, usually in C programming, or we call it as typically be any name. So, always we have seen in the building blocks for section. So, identifiers. So, name of a file is also by just by specifying or by giving any name, that last two characters that should be .c. That is very important, because so that is how your compiler will come to know it is a set of instructions which is written in the C programming. So, that we call it as extension of that program .c, or we call it as file name with the extension .c. So, once your compiler will because see in the computer we have so many files, so much of data, but compiler has to go and pick only the files which are ended with or which are having the extension .c. So, immediately it will compiler will just check only those files based on the name which you specify. According to that it will start compiling or start translating from high level language to the respective machine level language. So once you open the editor and type the program, then save the file name, save the file by providing the name of the file with an extension .c. Once you give that, so your file name must be, here I have taken the example is program1.c. Here this is the valid file name for a C program. So this is what first we need to do. Next, after the first step, so after the source program has been entered into a file, source program is nothing but the instructions what we have written in a file, that will be source file. That source program has been entered in a file, then you need to proceed to have it compiled. We need to be compiled. So the process, the compilation process is initiated by typing the special command on the system. We need to open a command prompt, because that's where exactly you have installed your compiler. You need to go and you need to start or initiate the compilation process by typing the special command. For a compilation there is a special command. What are those commands? We will try to understand going forward. So we need to give that, or we need to pass that special command to compile that. Okay. When that command is entered to initiate the compilation process, immediately we need to provide the name of the file, where exactly, or on which particular file name you have given the set of instruction to perform a particular task. So that's what. So when the command is entered, you need to provide the name of the file that was we have created in the first step, right, program1.c. So that name has to be given, the name of the file which contains the source program also we need to specify. That's what your third step. When the command is entered, the name of the file that contains the name of the file. So command is entered, the name of the file that contains the source program, that must also be specified. Once we specify that, suppose if you take here we are using the compiler as GNU C compiler. So how we need to specify, or how we need to initiate the compilation process, by typing the following lines. You see, it's GCC. There are so many ways to, but here we have taken that compiler GCC. That's the special command. We are giving the instruction to compiler. You go and compile the name, file name, that is program1.c. That's where we have written our instructions by using C programming. You go and initiate the compilation process. That's what we use this particular command. Also, otherwise we use another command, special command called cc program1.c. So once you pass these instructions, then automatically what happens, your compiler will start, or will initiate the compilation process. Next, in this step, so what happens once the compilation process is initiated, the compiler, what it will do, the compiler will examine, will validate, will check each and every set of we call it as instructional statements, or the program statement, which are a part of the source file. So it will check, or it will examine each program statement which are in our source file or source program, and also it will check and ensures that as per the syntax or semantics of the language, because that is what very important, because every language is constructed during, or constructed by using all these grammars, character set, everything. So here also we are talking, once the compiler will start compiling the initiating the compiling process, so the compiler will start examining the statement which you have written in that file, and then it will check whether the source file or whether the instructions what you have written, whether that is in the proper or that is having the proper syntax or semantics of the language. Here which language? C language, which is as per that or not. So suppose if it finds any mistakes with respect to the syntax or semantics, if any mistakes which are discovered by the compiler when during this phase, compilation phase, then immediately the compiler will report to the user and the compilation process will halt or will end at that time itself. You got this point, right? So whenever the compiler initiate the process, it will examine or it will check the syntax and semantics. If any mistakes with respect to the syntax or semantic rule is violated, or if any mistakes which found, then immediately it reports to the user as to the programmer. This is what the problem in this particular statement, the line number in this particular statement, this is what the problem is. Immediately it reports to the user and immediately it will stop the execution, that point itself. So, and also it will list the error, what exactly the problem, what is the mistake, or what exactly you have done the mistake. It will report the same thing to the user. So then the error has to be corrected. The user need to check what exactly the error is by just referring that report. The errors need to be corrected in that source program. So maybe again you take the help of editor and go and you just go through the source file or the source program and correct it. And then again you need to restart the compilation process. So once you fix the error or fix the issue, you need to restart, you need to start compiling from the beginning. So again say cycle repeats, you need to specify the special command and then the program name with an extension .c, then again it will start examining each and the statements which you have written in that C program. Then it will check again, it will check is there any error or any mistakes. If no mistakes, it will proceed from that particular statement. Okay. So always that's what the errors, they have to be corrected in the source program with the use of an editor, and the compilation process must be restarted. Next, all the errors, typically whatever the errors will which are reported during the compilation process, maybe with there are so many reasons or so many violations with respect to the syntax. Some of the some points may be due to an expression that has unbalanced parenthesis. Maybe if expression says that result is equal to parenthesis of a plus b into c, you are just you are maybe the parenthesis or the brackets which you have used during in the expression may not be proper, or maybe sometimes whenever you return the C programming, you may be you might have missed the termination statement, that is semicolon at the end of statement. So these kind of some syntactical errors which will be defined, or sometimes a is equal to 10. What exactly the a is? It's a variable but which is undefined. So always in C programming, before using the variables, you must initialize it, but that is not, or you must be defined. If it not defined, then again that is also an error. So these kind of issues. See, typical errors, what might be the typical errors which are reported during this compilation process? Maybe an expression that has unbalanced parenthesis, that we call it a syntactic error, or maybe due to the use of variable that is not defined, which if you are not defined that variable, that we call it as a semantic. Got the difference? Syntax, syntactic error, semantic error. If someone asks, discuss the different types of errors, or what are the errors that will be that will be reported by the compiler, maybe yes, you can classify like this: syntactic error and semantic error. Syntactic errors which are likely to be these kind of scenarios, like if expression contains unbalanced parenthesis, might be a syntactic error issues will come. If variable is used but that is not declared or defined, that is semantics. You have to, that is must, that is the syntax, semantic. So these are the some typical errors with respect to the compilation process we will come to know. So next step is when all the syntax, see now the job is first phase or during the first step we have created the source file, we have opened the editor or the notepad, we have just typed our instructions and saved using name of the file with an extension .c. During the second step we have whatever the instructions we have written or the source file we have written in the step 1, that has to be that we have compiled in the step 2. So during the compilation process it will check all the errors with respect to the syntax or semantic or syntax. So if any error it will report to the user need to fix that, and then we need to go or we need to proceed with the step 3. In that step 3, what is that? We are just when all the errors has been fixed, syntactic and semantic errors have been removed from the program. Now your program or your set of instructions which are free from the errors. So the compiler then it will proceed to the next step. It will take each and every statement of the program and translate it to the another form. That form we call it as which is equivalent to the machine level program. So now that is the actual job. So what happened during the first phase, first step we have created with a particular file name. Second phase, by specifying the special command, we have compiled the program to check any it is validated any syntactic or semantic error that has been fixed by the user. And now in this third, when if there is no error or syntactic or semantic error, then it will proceed to take each and every statement of the program and then it will be translated into the respective machine level language that need to be perform the task. That is what in the step 3. Now, so after the program, now we have done all the errors are fixed, it is translated to the low or its low level form or nothing but the machine level language. Next your fourth step, that is after the program you have translated into an object code, now it is ready to link, ready to be linked for the execution. So here the loading is done so far, now it is ready for the linking. So this process once again perform automatically whenever you give cc or gc C command is issued under Unix. This is particularly with respect to the Unix operating system. See, n number of times if you compile, whenever you compile, always we pass this special command, automatically it will be compiled. Once you pass your file name with this particular special command. So now the purpose of linking is what? The purpose of linking phase is to get the source program, originally whatever the source program you have written, right, that program should be into the final form for what? For the execution. Because so far what are all the things we have done? It is a compilation just to find out what are all the compilation issues with respect to the syntax or semantic, then we have removed all those errors. Now it is translated into the respective machine level language. Now it is ready for linking for the execution. That is the purpose of linking phase. If the program uses other programs that were previously which are already processed by the compiler, because see every time we are keep on doing repeating the same process. Now if the program which uses the other programs that were previously processed by the compiler during this phase, this object program is also linked with that, linked together. Clear? So if the program uses other programs that were previously processed by the compiler, then during this phase the programs are linked together. Now next step is programs that are used from the system program library also search and linked together with the object program during this particular phase. So sometimes we have some system program libraries also, so that will also be searched and that will also link with the object program in this particular phase. Because we are going to use so many instructions, some of the instructions are from the system library and some are directly the user defined instructions. Whenever you have system defined or then libraries, that will be linked during or searched and linked with this object program in this phase. And the process of compiling and linking program, we also call it as building. Compilation is done and then we are trying to link with the object program. That concept we call it as building. That means ready for execution. Building, that concept is building. Now in the step 5, what we do? We will try to execute. Now everything is done, we have written, we have saved, then compilation, linkage, fix all the errors and then link your program is ready for linking. Now link your program, even if you have any system libraries, everything you can link and make it ready for execute. Now immediately it will execute the program. Once the execution is started, immediately the computer, the program will be into the computer memory. For what? Initiating the execution process. So when the program has been executed, each of the statement in the program that will start executing sequentially one by one. If the program expects or requests any data from the user, so suppose if the user wants to find out the addition of two numbers, then compilation everything is done. Now compiler is expecting you need to send the numbers. So that is what, if the program demands or requests any input or the data user need to feed, so that we call it as input. So that's because your program is expecting or your set of instruction is expecting some data. That data you need to, as a user, we need to provide, that we call it as input. So then your program will temporarily suspends its execution till it receives the input from the user. Once it receives the input from the user, then it will be start continuing the execution. So like that, so that's what, if the program requests any data from the user known as input, the program temporarily suspends its execution so that the input can be entered, or the program must simply wait for an event. Event has to be triggered somewhere. So such as mouse being clicked to occur that particular event. Now the results that are displayed by the program. So now you have whatever the system expects or the program expects or requests the input from the user. Once you enter the input, it will take that input and it will process all the instructions, and it will make it ready, or it will process that all the input, the instructions along with the input, and it will make ready the output. Once the results that are displayed by the program, that is, we call it as an output. Input we have given, the program will start processing that data along with the instructions which we have given in the source program, and finally it will give the results. That result we call it as an output. That will be populated or appear in a window, sometimes in the we also call it as console. So this is what are the last step after the execution. So if the program does not produce the desired result, it is necessary to go back and reanalyze the program logic. Sometimes, yes, there is no syntactic or semantically there are no issues at all, but still somewhere, like assume addition of two numbers, 2 plus 3, 2 and 3 is our data, 2 plus 3 we are expecting that should be the 5, but you may not get sometimes that 5 result. So that is because of your logic somewhere has missed. So that to fix those issues, again you need to go back, revisit the program, reanalyze all your instructions with respect to the logic. So if any issues, you just fix those issues, and then again the same step, you repeat the same steps, compilation, execution. Then all these things will happen internally. This is known as debugging. step-by-step procedure to fix the issues. We call it as that will happen during the debugging phase. So in this attempt, or in this particular phase, we are trying to put our efforts to remove all the problems or issues with respect to that particular program. So to do this, we maybe we need to change the logic, right, to make or to get the proper results. Sometimes we might need to change the logic of our or we need to change the source program. No problem, still you can go back and change the program. You do the same steps whatever we have done so far, then try to get the desired output as per the requirement. So whatever we have discussed during the steps, just the same thing through the flow chart we have we will try to understand. First we need to start, then if there is any edit you need to do, you just do that editing things, and then you try to compile, or if it is a high level to machine compile, if it is assembly language we need to use that assembler. So then after the compilation again we need to check is there any errors or not. If there is no error, then go to the next step and try to link your source program. So if there is any errors, go back and again edit the source program and then recompile it and then check the errors. If no errors, then go to the next phase. Now it will start linking. Okay. Once the linking has been done, then it is trying to execute. That means it will be your source instructions are nothing but it will be in the executable object code. Okay. So and then so that executable object will be into the executable object code. So that will be in the form of a dot output. So then again that object code will execute and then we are checking the results. If results are proper as per our expectation, then it's done. If not, then go back and again edit the program, do the same steps. See, after the compilation what we will get? We are trying to compile the source program, that will give the compiled program. So usually it will be file.c. We are passing these. See, these are all the Unix operating system. VI editor here we have used VI editor. So we are just using the special command cc and name of the file.c. Once we have compiled, your compiler will just check and examine each and every instructions. Then it will check. We are checking the errors, and at the same time your object program is also ready, because if I have 5 statements, first 2 statements are fine. So those 2 statements and then third statement, problem with the third statement, there we are checking the errors, and at the same time the object code is also be ready, and at the same time that object code will link with the linker. So again we will try to execute all the program. If during the linking phase, if any need or any need of system library, you go and get it from the libraries which are required as per your requirements. You just go and get it that from the system library, then execute. This is what the overall, whatever the steps we have given, that's the entire will be in the flow chart. So now the same, whatever the steps we have discussed and whatever the notations we have seen during the flowchart discussion, we will try to understand the same compilation and execution through a program. So the program is just to add two numbers, simple program to add numbers. So now with this program we will try to understand how the compilation and execution will happen. So this is an header file. So first thing, you remember recall the concept of structure. We have used comments for the documentation program purpose. Here the documentation we have just mentioned what program it is. Program to add 2 numbers. Your compiler will not consider this statement for the execution. Next statement, we have included the header files, libraries into our code. That is the reason # include stdio.h. So next is global variable declaration. That's what we have discussed in the structure. But it's not mandatory. If you need, yes, you can go and declare those variables outside the main. If not, then you can just continue with the main. Here we have written main function and then start with the main. So once it finds the main function, then immediately it will start the execution. Here we have written one statement called v1 comma v2 comma sum. What is this? These are the variables of type int. I think going forward we will discuss the type, data type, what type of data you are going to store, integer without decimal numbers, decimal places. We have whatever the digits you have, that all we call it as without decimal places or the values, we call it as an integer. So here we have declared three integer values v1, v2 and sum. So that's what v1, v2, sum are the variables and int is the data type. That's what we have declared. Now we have assigned a value 150 to the variable v1 and similarly 25 to the v2. So now what is our program? Add two numbers. Add means just we use the arithmetic operator, there is a plus. So sum is equal to v1 plus v2. You take v1 and then add with v2, and once you compute this, then you store the result into the variable called sum. Now again you print that, printf. To print that we use the statement called printf. Within that parenthesis, within the square bracket, see here, colon, within the quotes, double quotes, the sum of percent I. It's like, what is that? We are trying to display the value of type integer, and again integer is, again we are displaying the result, because what is this I? It's an integer. So we are just displaying on the console whatever we have. v1 is of type what? We have said already, it's an integer, there is a I. v2 is also an integer, that's a percentage I. v1 and v2 is, we got the result, what is that? Sum. That's what sum is equal to v1 plus v2, that is stored in this, and slash and this escape sequence. Once it publishes the result, it will go to the, it will insert the new line. So now you close the quotes, double quotes, comma, there is a syntax, whatever you have given here, that will be displayed in the console. Now you print this, where first I will display, will take this value, and second I the v2 value, and the third one is the sum. And then we use the return. Why return? Because your main function we have used int. Int, whenever you use other than void means null, it won't return anything. Other than that, if you use any specific data type, then we must use the statement called return. We are not returning anything, everything we have just processed here and we have displayed here only, but still, even though if that is the case, but still you need to return, because since you have used main function need to return the integer value, so you just return 0. So once you compile, the entire statement will be compiled to check any syntax or semantics error. If no error, then it will be linked, and then it is expects the input 150 and 25, then it will compute, and that object code will be converted, and then these results will display. Output will be the sum of first I is 150 v1 150, and this percent I is nothing but v2, that is 125, is equal to this last percent I is nothing but it's related to the sum, that is nothing but 175. This is how it executes. So just we'll quickly will understand how exactly the compilation and execution has been done. We have discussed during the steps how many steps we have we have seen what are the different steps we have used to compile the program from I level to the machine level, or the source file to the object code, and how we have fixed the issues with respect to the syntax and semantics. And even though after fixing that syntax semantics, there is a possibility of logical errors, that you need to go back and again you fix those logical errors, and finally once if there is no errors, that will be converted into an objectable code that linked to that has to be linked, and then finally your output. That's what we have seen, the steps, flow chart, and also through an example we understood how the execution, compilation and execution has to be done in the C program.